right? They have two different products. They have browser claw and browser OS itself. So play around the two products. It's open source, which means it's probably free, right? They don't charge you for anything. So just play around it. That's the point. And what does this kind of system does? Imagine that, like I said, you have tasks to do, right? That, for example, you have an Excel to fill up, or you have a document to actually convert to an Excel document, and create different spreadsheets and all that. I mean, I expect that it should be able to do it for you. So you can be able to tell it that, okay, this particular browser has, or this particular document has everything that you need to actually create the Excel document, and it will continue to do that for you. And you can see it basically move your mouse, and take items like it's take action as though it's you that is taking the action. At least when Perplexity browser came out, Comets, it was free. I used it that time. It was very interesting. Like, I used it to complete an entire application, and it was really good. So, but now that it's paid, and it's good for me as well, because as at then that I used browser OS, they are was still at its early stage. So I'm guessing there are more interesting stuff, like you can basically sleep and tell it to clock in for you at work, check out by X amount of for example, if your work has like a login time and log out time, you can tell it to ensure that your screen never goes off. So it's actively doing something in the browser every 30 minutes. There are a lot of use case for it, ideally. So just like I said, play around it and let me know what you think in the next class. All right, let's start class today. I want to go to light mode. All right, so yesterday we were supposed to do a bit of to learn what front end um, mobile is, and then discuss a bit about buy versus build strategy, right? So I will try as much as possible to go through everything, and then also cover SQL today. So again, for SQL, I might not be doing live practical for us, but I will give you a platform that allows you to do that. So normally I would have built the platform for you the way we used to do, but I would rather, since there's a platform that does that already, I'd rather you could just go to it and use it. And the platform even have a dedicated course in case you want to learn more with HTML, SQL, and all of that. All right, so before we start, I think I already explained front end, back end, and and all of that before when I was explaining APIs. But now I'll give more context to it, right? When you hear front end basically means what the user can see, right? The part of the system that the user can see, the experience basically for the user. Front end can also mean some parts that the user is not seeing, but affects the user. So any part of the system that affects the user, so to say, is a front end. For example, um, you are trying to load a website and it's taking 10 hours or 10 minutes to load. This is not necessarily a UI or a button, right? But it is part of the work of the front end because it affects your perspective towards the system, right? So the front end is one that is responsible for ensuring that you have lazy loading. What do we call lazy loading? Basically, is that process where you save up a version of the website in your browser so that the next time you try to visit that particular website, it doesn't have to go and make requests in the backend. This is done, or caching system and many more like that, basically on the front end, right? So there's a general misconception that front end is just the things that you can see, but no, it's not just the things that you can see. Front end sometimes also entails the performance that is involved in getting what you can see available to you. This can it can include speed, it can include many other things, right? For example, a company company can say that for their front end solution, they want to move away from microservices or to using a from using a monolith approach to using a microservice. I'll say explain what monolith is today, if time permits us. So please, because of yesterday's class, I might extend a bit today. All right. So um, what exactly is monolith? I will explain when we get to backend. It makes more sense at backend. Monolith is like, how Google has Gmail, they have Google Doc, they have Excel, right? Each of these tools are a tool on themselves. So you can build it in such a way that all of these tools are separate from each other. Or the best example to give is our banking app in Nigeria, right? You have OPay, and inside OPay you have bank transfer, all of these features. You can build it in the back end. That's why I say backend is better to explain, but front end might be harder to explain. But you can build this system together. So which means all the codes are merged together, right? And then you can build it in such a way that they are separate services, right? But they use similar components. They have components that they can reuse, right? So if I go to transfer, or I'm on pay bills, the UI and the experience still feels the same way, right? So that's why you hear people talk about micro frontend. Micro frontend is just the idea that all of us are actually connected to uh that single front end, but each service or each team now have their micro version of it. So if, for example, Innocent and Constance are in group team A, let's assume their team is the one building WhatsApp, and Ike, Joseph, and Adiola are in team B, is their team that is building Instagram. And these two companies are using microservices. What it means, or should I say micro front end in this case, because we're talking about front end, what it means is that if Ike decides that no, this color of this button, I don't know, it's too blue. Let me make it lighter shade of blue. The moment it changes that color of that component, it affects the product of Innocent as well, even though like their product is meant to do something totally different. So that's the idea behind micro frontend. Instead of team A building their entire front end and then team B building their entire front end, and then you have redundant components everywhere, and then you are managing components everywhere. For example, you are now asking the person, which kind of blue are you guys using? They say, oh, the blue is the blue is deep blue. So okay, no problem. We'll use deep blue as well, right? You now have deep blue on this side, deep blue on that side. You have different part of the code just scattered everywhere. You can have a single component that can be reused by every other person, right? So this is what we call, this is the idea behind micro frontend. I just wanted to mention that. But now let's go into one of the most popular part of the front end, which is browsers, right? Before mobile app even became a thing, most of the softwares we have in the world were web apps. You have to open a browser to access them. Some of us here, at least, we did Jump, or we did. I think WAEC is now also CBT. I don't know. Not been in the educational space for a while, but we did exams, at least in our school. I'm hoping that your school has CBT. But yeah, you did CBT exams. And even with these exams, these are some of the first softwares that you were exposed to. They were usually in the browser, right? So the big question is, how does the browser really renders a page? How does the browser understand that this, for example, how does he understand that this my code uh what is it? That all this rubbish that I'm looking at, right? All this rubbish that I'm looking at, how does he understand that this is what I need it to show us? Oh, that I need this part to be like this, and I need this part to come like this, I need the logout to be at the top here. How does he know all of that, right? The way it does it is that, number one, it passes that particular code that you have, your HTML and everything, that your code. it takes it into DOM. DOM is basically an object model, right, in your browser. It takes it into that place and then it builds it inside it. When I say build, think of it this way. When you hear the word build, what should come to your mind is like when you cook food, right? You have raw material. You have for example, you want to make pounded yam, right? You have the yam, it's cooked already. You have the mortar, then you have the pestle, right? You have water, all those three or four, five, six things, and then you have your hand, right? To make pounded yam, you have to combine everything together. You have to do a certain effort to make sure that it becomes the pounded yam that you want to eat. The same applicable to any food you want to cook. So the same way, this your raw code that I showed you right now, something like this that your developer has written, right, needs to be taken because again, it's just raw. It's like your rice, maggi, and everything that has not been cooked, right? We take everything now and then put it inside the DOM. The DOM, like I said, is an object model. So the DOM can recognize, why do we call it an object model? Because it can recognize what this particular code is, what that particular code is, it basically understands every element of the page. So it is the one that actually takes that in and converts it into something making sense. However, aside from HTML, there are also two other components of a website. The first one is CSS and the second one is JavaScript. CSS is, now when I'm trying to explain CSS, it's always a bit complex for me because with my students, eventually they get to realize that you can also use HTML for styling, right? But HTML is harder to style. So CSS is ideally designed to make it easy for you to style your website. For example, me deciding that, oh, I want a line, a blue line, on this side of my website. I want, like, when I click on this, I want it to change to black, right? That kind of experience is something that CSS can help you do in no time. If you were to do it with HTML, it would take a lot of coding, right, to even create this segment. I mean, in most cases, not really, but it would take a lot of work because probably with HTML, what you would have to do is create a table. Every of these things will be a table, one column table. And then each of these each of these lines that you're seeing will be rows, right? And then it gets very complex easily. So your DOM also takes in that your CSS, which, like I said, is meant for styling. CSS is basically cascading style sheets. They are basically the way you style your system, like, oh, what color should this be? Where should this be? Oh, I want it to be, I want it to be rectangular in shape. Like, I want when I, over on it, those kind of things, right? That's CSS. Now, JavaScript is basically giving life to your code. Again, I'll explain it in the simplest way. JavaScript, when it comes to front end, is that guy that gives some sort of life to your code. For example, you see this guy here that is just dancing here since morning, right? The JavaScript is the one that allows that action to occur. So JavaScript, as the name implies, is a script that you add to your website that can take certain repetitive tasks within the system that gives it that vibe that you see. For example, you go to a system that has animation such that when you scroll, it does some like it does different, activities. Maybe when you click on this, it just blows out, right? That kind of action that is animated can be achieved with JavaScript. So again, like I said, in the front end, especially for browsers, there are majorly three components. Of course, there are other components when you start thinking about it, but the major ones are these three. You have the HTML, you have the CSS, and then you have the JavaScript. So the HTML is the main code that handles the actual structure of your website, the index file and many, many more like that. And then the CSS, like I explained, handles the styling, right? So if you hear your developer saying, oh, I'm working on the CSS code, blah, 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 what they're basically saying is I'm I'm working on the code, on the part of the code that actually styles the website. Now, when you're building with AI, right? For example, this platform that I'm building, where is it? Yes, this platform that I'm building right now. If you check here, right, in the code, you will realize that literally all of the code is either, like most of the code is either .js, which is the JavaScript part, or again, like I said, there are more components, but the major ones, right? So you have .js, you have, if I go into the main components, right, I will still explain TX. It's complex, but I'll explain TX very more later. But you see, most of it is .js, and your main index file. Where is it? Basically, you most likely have HTML, and then I will explain why you are seeing .txt here. TX is what we call TypeScript. It's a different conversation entirely. But in most cases, you always have something like HTML. Why is my mouse doing this? Sorry, I'm not sure why my mouse is acting up. Okay. I think this is a very, 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 very bad example. Let me go to the code itself. Right? You can see .html, 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 right? So most of these documents are HTML defines the structure, basically. I will explain what you saw in the vibe coded website very soon, but I need to understand the basics first. So you have HTML, which defines the structure, CSS, which basically defines the styling, and then the JavaScript, which adds live to your website eventually. Then after it has passed all of this into the DOM, like I told you what the DOM does, it brings everything together and ensure that they work together, then makes your pounded yam for you. So after it makes your pounded yam for you, right, then it converts it into visible layout that you can see. Then after converting to visible layout, usually that layout is not probably, it doesn't have this color. All of this happens in seconds, by the way. It doesn't have these colors and everything, and then afterwards it has the adjustment to it. Now, this part happens every single time you load a website. I don't know if any one of us have noticed that if you open your website on, I don't want to share this so that it doesn't look like I'm shading some people, right? My former laptop, right? I used to think that laptop was the best laptop in the whole world, right? Because amongst my peers, when I bought that laptop, everybody would be like, wow, wow, you are using wow, and all of that. And my color used to be the color that everybody used and say, oh, Michael, please let me check if this color is correct on your end, because when we were starting our career, my friends, I used to write code earlier on in my life. And my friend, we used terrible laptops, all those Dell, right? And sometimes they added blue, but it's showing as green, right? So I felt like my laptop's color was like the best color because everybody was always talking about how the color just come out, and all of that. The day I got my laptop, I realized that I was colorblind because I started seeing some websites differently. You load a website and you're like, okay, did these people change their UI? And then you take it back to your old laptop, and you're like, oh, it's not their UI, it's my screen. So depending on the processing power or the systems that you're actually loading the website, right? It then decides how it actually shows it to you. That's why in some systems, right, certain animation would not work on some systems and then it works on others. The same thing applicable to mobile devices, right? You see some apps tell you that, hey, if you are using any Android version lower than this, please forget about downloading our app. It will not work on your phone. Just take ads, right? Why? because the requirements, that particular processing power for that device cannot handle the kind of work that you do. So like I said, this paint and composite happens every time you load the website. So which means if you load the website on a system and you load on another system, you might have slightly different experience depending on what you experience, on what device it is. And this also determines how the UI looks. For example, on platforms like you open a website and on mobile, on your desktop is flat, like it's so flat. But when you are on mobile, for example, if I zoom in, right, it's showing here as navigation. So if I'm on a smaller screen, it has a navigation at the top. If I'm on a larger screen, the navigation is not at the top. All those kind of activities handled by this paint and composite, right? So basically it transforms it based on what is available on your CPU, or in the case of your GPU. Now, I said the other time that with the AI, that I need to actually explain something to you guys. So because writing HTML and CSS is very, very stressful, right? Like you have to write every single line of code. And some things don't change, right? Every website has a nav bar. Every website has a button, right? Literally every website in the world has a button. There's literally no website in the world that doesn't have a button. I have not found one that doesn't have a button, because why are you creating a website that doesn't have an action, right? Every website, either you like it or not, has navigation. The navigation might not be at the top, like my own now. Navigation is not at the top, it's by the side, right? Every website has certain things that characterize them. So to ensure that we don't have to write those things over and over again, something we call frameworks were invented. So you have stuffs like, you hear people say, "Oh, I use React." Some people say, "Oh, I don't use React, I use Vue," right? Other people say, "Oh no, I don't do Vue, I use Angular," right? So those are just frameworks. They are like, um, think of it like boilerplate. There's also boilerplate anyway, so let me not confuse you. Boilerplate is used usually on server side, right? But they are like your um yeah, you're like your templates, right? It's like, how do I explain it in a way that you guys would understand? It's like a Canva. Like imagine they give you like, aha, very good example. How many of us have gone for sip and paint before, right? If you go for sip and paint, I mean in a very good place anyway, they will give you the blank Canva, but they don't just give you the blank cover. If you go for advanced one, yes, they'll probably give you very blank one. But if it's just one that they just want to test your painting styles, the canvas will not be extremely empty, right? It will have the shape. The lines would have been drawn on it already, right? For example, if it's a woman that you want to paint, aha, a very good example. Sorry, I used to hear myself. That's whenever you hear me say aha, I'm hearing myself tell me what to say. All right. Um, when you a very good example is, I don't know if you've seen a child learning how to paint, right? They will give them this book, right, where they have where they already drafted out what the it's called something, workbook, paint workbook for kids. Aha, good example. Yes. So this is the example I'm talking about. You see, this guy they've already given you like a more like, you already know that you are painting butterfly, right? And this one is even nice. It already tells you the color you paint all of them. Imagine it's a blank canvas. They are not telling you which color to paint all of them, but they're just telling you, okay, you need to paint number 1, you need to paint number 3, you need to paint number 4. So you choose the color that you want, right? Something like that is why we invented React. Because we know everybody at the end of the day will paint a butterfly. So why should we now let everybody now start drawing their own butterfly? It makes no sense, right? So instead of allowing everybody to draw their own butterfly before they paint it, we draw it for them, since everybody will paint the same butterfly, and then tell everybody to now paint, because that is the part that we actually need customization for. So those things are what we call frameworks. So you have React as one of them. You have Vue. You have Angular. We have quite a number of them now, right? But the most popular ones are these three that I mentioned: React, um, Vue, Angular. When I was writing code, when I used to do front end, I used to write Angular. I used to write Angular because I worked at the fintech and they were using Angular at the time. It's one of the craziest framework anybody could ever use. I hate it with all my life now. Maybe that's why I didn't eventually end up as, as a developer. And why was it very stressful for me? It's because Angular was discontinued at some point by Google. It's owned by Google. That coding framework is owned by Google, and it was discontinued at some point. And because of that, there's no support for it. So if you face a challenge, if you are trying to find a solution now, with AI, you can just chat, AI, something is wrong, right? In those days, there's something we call communities, right? You have to go into community and then ask people, how far I'm going through this, or you try and search. There are certain platform. I can't remember the names of now because I've not written code in a very long time. But there are certain places that you also go and check if somebody have experienced what you have experienced before. You just put on Google and then you can find similar people that have experienced it. How did they resolve it? And all of that. It was easy to find solutions easy if you are easily if you are writing React or Vue, right? But if you are doing Angular, if you face a challenge, right, you fight, solve it yourself. By the time you solve it, you don't even feel like sending to one community. You say everybody should go and face their problem, right? It was so that's why Angular is not very popular anymore. However, Angular is still very, very popular in the fintech space. Why? Or in the finance space? Because it's actually one of the most secured framework you find out there. Very security conscious. They were very security conscious when they were building it. So most of our big architecture banks, like top banks, some of their core architectures are written in Angular, C Sharp, C++, and programming language that nobody uses anymore. But those languages and frameworks are very, very structured and sound, right? So to say. All right, so you have them, and because of React and some of these guys, they now introduce another type of JavaScript. Remember, I said JavaScript is basically to help you handle the whole thing. Now, JavaScript initially was designed to add life to your HTML, basically um make your like I said, animation and all of that. But now with frameworks, we now have TypeScript. TypeScript now does not just add value to HTML, it also now comes with its own structure. So that's why you see that when AI builds for you, you most likely not find any HTML, because TypeScript itself has the capacity to bring structure to a project, right? So you most likely find a lot of TX, TXX, right? You find TXX, but when you look inside, you will see that it almost looks as though you are looking at an HTML, right? So if you look at this guy, right? You see the way it's structured, and all of those blah, blah, blah. If you are looking at this as well, it almost looks like you're looking at the same thing. Why? Because TypeScript was built with that in mind, right? It was built with, think, when they were building TypeScript, they thought about, think of JavaScript meets HTML, right? Something like that. So most of the new frameworks we have and all of that, for example, we have Node.js, we have Nox, we have Next, we have Next. We have a lot of them now, right? Most of them use TypeScript, which makes work easy. Even if you are writing, for example, a Flutter app, a mobile app, and you're using Flutter, it also comes with TypeScript. Again, please don't feel like these things are very much. You get to learn them over time. All right, so what am I trying to say in essence? That we don't have to write our HTML code manually, everything manually again, right? All these functions, you have to write everything from scratch. All you have to just install is dependencies. install node dependency, and you are good to go, right? So, which is where all this ecosystem came in. So they handle state management for you. Like I said about lazy loading the other time, right? Some code that you have to write manually before. For example, I need my website to be fast. I don't want everybody that comes to my website every time to always request for the entire website from the server. No, I want them to load it one time and it will save in their browser so that next time they load it is loading faster, right? Those kind of things before you have to write the code manually. But now with frameworks, it's already come as a package of the frameworks, right? It makes work really easy, right? So again, this is what frameworks ideally looks like. So we have certain front end metrics that you probably want to consider when you build, right? Um, Remember when we were talking about building features, we said acceptance criteria. Consider these 5 metrics or 6 metrics, 5 actually, when you are actually building your app. Number one, we call it LCP. LCP is basically how fast your main content load. Now, what does main content means, right? I'll show you an example. I'll show you an example of what main content means. I'll go to an admin board now, right? You see this admin board is taking time to load, right? Because it's getting information that are not the main information on the browser. But if I go to my website and, if I go to my website and reload my website, it loads faster, right? I mean, even though it's still loading on the background, I can see my browser, I can see my result already. So that is what is actually saying that LCP, sorry guys. So it's saying that LCP is basically how fast your main content load. Ideally, this should be around 2 to 5 seconds, right? And INP, which is the interaction to next point, is how fast the page responds to interaction. For example, I move from one page to another. How fast does my page respond to that? So this is also something that you should also consider when you're thinking about metrics for your front end. Another one is cumulative layout shift, like how much the layout jumps around, right? And this ideally talks about your ability to actually like come down to another navigation, go down to another part of the website, right? How easy is it for you to navigate ideally within your system? Then time to first byte. Time to first byte is not talking about the user interface now, because the next time you log in will be faster. But it's talking about your first request to the backend. Like I said, I gave you an example right now. I said it should be ideally less than 800 milliseconds. It should be less than 1 second. So let's do a bit of example. So I show you that probably my system is not as smart or as solid as it should be. So if I go to admin now, right? It's loading. All right. So I've gone to admin. Sorry. I want to check how long it took. Sorry. Sorry, they will on my gen very soon, so you guys will be able to see the full screen. Okay. So you can see the time it took to actually get that data, right? You see, the highest time on my page is 757 milliseconds. So at least on the I octave or on the I base, what we are saying is that at the most craziest point ever, make sure that that your first time, like your request to your backend has to be less than 800 milliseconds. So less than you can blink, basically. When you send a request to your backend, your response from the backend must be as fast as you blinking your eyes, basically. Give me a minute, please. I need to. Okay, lovely. All right, then FCP defines. I need to move it back to the other screen. Okay, so FCP defines the first contentful paint. Remember, I explained what paint is for you guys, right? Can you remember? Can you guys remember what I mean by paint? Like the first. Sorry, give me a minute. Okay. Um. Sorry, work and everything. Ah. All right. So first contentful paint is the time for all the information on your website to actually load, right? Should be less than 1.8 seconds, which is again almost like you blinking, right? So always understand this. And yes, these core vitals are very important when you are considering how fast your system loads, especially how fast your system loads. You have to consider it before you do any release. I always advise people, even in my own personal website, right? You'd see that it is part of the things that I actually look forward to. And then you have to track it so that if at any point you just starting, for example, like I said, it has to be less than 2.5 seconds. This has to be less than 1.8 seconds. So if all of a sudden it started going to 1.9, right? Your system should send an alert to you that, Baba, something is wrong with your system. And then you can call the attention of your developer or any other person in your company into it to actually get it resolved, right? I said I was going to be very fast with all of this. I already explained a bit about React. Okay, so now let me go to front end when it pertains to like mobile apps. All we've been talking about so far is front end when it pertains to web apps, right? When it pertains to mobile app, the two top ones for me is React Native and Flutter. Flutter and React Native are also frameworks. Remember what I said about frameworks? They are built in such a way that it helps you so that you don't have to build everything, right? Some components are already inbuilt inside of it to ensure that it's easy for you to just, build what you need to build, not the entire things that you don't need to worry about, things that don't change. Like, how do I render the website? Like building DOM, it makes no sense, right? Those things are already been built. Every website will have a DOM. Every browser has certain requirements for every website. Those requirements are, you don't need to write their code yourself. They can already come with a package, right? That's why most people use frameworks. Now, to build mobile apps, especially when you are thinking of cross-platform, which means you want your mobile app to be able to work on iOS, you want to work on Android, you want it to work on any multiple device, then you have to consider two major ones. Number one is React Native and Flutter. Flutter is newer than React Native. React Native is one of the most respected, complex, and um, go to in most cases. So in my defense, I'll probably tell you, oh, okay, go to React Native if you want to build any app. Flutter is good as well. It's even simple, it's lighter, right? And Flutter sort of can also help you build your mobile app in a way that you're already building the web app as well, right? But React Native is stronger when you think about it. I would leave this for you guys to read. It's just advantages between both of them. So like I gave you for web, what are the vitals to think about? For mobile, when you're building your app, these are the things that you need to think about, right? your crash rate, how many percent of your session end up in crash. That means how many percent of your customers open the app and it crashes. ANR rate is basically application not responding. Your customer wants to send something, but it's not going through, right? What is the number of people that are actually going through that? App Store rating is also very important, and your deep links. Now, I'll explain why deep links are also very important, right? Remember when I was talking about um, uh, in web, the ability for the website to actually load faster or make things easy for you, right? That is what deep links are for mobile apps. So you build your app, you build application inside your app in such a way that it is easy to track, like the navigations link to each other, right? On the stable manner, right? I can navigate from one place to the other, and easily I can navigate to the other place as well at an easy rate, right? Those kind of things. I wish I could actually show you what it looks like to actually push your first app to production, but I think we can do that next week alongside the career this thing. Maybe we can build a app. So all of you think about a app that you something simple. Not don't tell me you want to build a app that will save Nigeria from corruption. No, a very simple app, right? It can be a calculator app, right? A simple app that you feel like you can actually push to App Store or your Play Store, right? Think about it. And next week we'll do live coding session where we use AI to build the app. All right. So when you push your app to Apple Store, Apple is very hard basically to get your app approved on Apple. To even get a developer account, you need to have an Apple device like a MacBook or the other thing. If not, they will not approve your developer account with your money, right? You even want to pay the $99 that they require. They will tell you, Baba, go and get a MacBook. If you don't have a MacBook, we don't want you to have a developer account with us, right? So that's one of the craziest requirements. And another requirement is they have a very crazy requirement on what your UI should look like, how your button edges, and many other things like that. They want every app in their platform to look a bit similar, even though they are not the owner of the app. Like even though Apple is not the owner of your app, they want your app to have something similar to other apps, right? On the platform, right? The button should have a certain vibe to it that when somebody looks at the app, you know that okay, this is on an iPhone, it's not on Android, right? So you have to consider that when you are building, especially with your developers. When you are testing, especially, and you notice that this app is looking like like you're using it on iPhone, and then it's looking like you are using it on Samsung, please return it back to your developer. Why? Because Apple will not even accept it in the first place, so you won't be able to push it, right? So those are some of the things you have to consider. And yes, I already explained what stage rollout is. You roll out to a few percent of your users over time. Google enforces this. So if you want to put a app on Play Store, you can't just wake up and say, I want to push my app on Play Store. Google will not allow. You have to first give it to a certain set of people. They have to use it for, I think, 12 days. Those people, whether they give it back or not, those people have to use it for 12 days. I think about 10 users. Then if they use it for 12 days, they have to use it at least 1 out of 12 days. And if after that, can you now move forward to the next stage? And the next stage is also another test. Then after that next stage, that's when you can actually push to everybody publicly, right? To everybody, right? Understand that. I already explained feature flag. Then OTA updates. Basically, this is used for hotfix. I explained hotfix for you. That means things you want to change something immediately in production, right? With mobile apps, it can be very tricky, right? It can be very tricky, but you should always consider this, especially for your Apple fixes, right? Look on MacBook, sorry, on Apple Store, sorry, App Store, on your Apple Store, you can't push anyhow, right? So you have to ensure that your app is very good before you push, right? So even if after you push, then there are also other ways that you can also push very fast. So that way you can ship your changes without necessarily changing your app review and all of that, right? So again, this is what the whole of AI, I say AI, the whole of front end, what front end ideally means. Now, quickly, I'll go into build or buy. Build or buy. I'll just explain it briefly, and then you guys can read up on it. What does build or buy means? As a product manager, right, you have to make this decision. I gave you an example. My company just acquired another company today, like recently, and now I've been working on M&A. We call it merger and acquisition. So we take some of their systems and put it in our own system, and like that. And usually when they are deciding this, they come out to meet you and say, hey, Michael, we're buying this because it will be useful for your app. Instead of you building it, it will just, add it to it. How do you think? They'll tell you to review, right? In most cases. Now, how do you decide if we need to build, buy, or partner? I'll say number one, when you are building, right, you have to ensure that we are building this because if somebody else is owning the infrastructure, we are building this because if someone else should own the infrastructure, it will mess things up for us, right? But if we own the infrastructure, it gives us more power. I'll give you an example. If, for example, you are building a delivery app, right? All that you'll be doing with the app is deliver. Sorry, give me a minute. Something is wrong with power. Sorry. Okay. So, for example, like I said, you're building a what do you call it now? You're building a logistic app, right? You're building a logistic app that allows people to maybe place order, tell somebody to go and pick up an item for them and all of that. Now, where's my mouse? Okay. Now, the logistic app requires customers to pay on the platform. And you decided that no, instead of using, we need to have a wallet. And then you say, okay, you want to have a wallet in the app so that people can, see accounts. You want them to have an account balance. So let's assume the name of your delivery app is Dogo Delivery Company, right? Now, you want people to be able to see when they want to transfer, they will see Dogo Delivery Company in the list of banks that are available when they want to transfer money or they want to deposit or, when you think about it, it's a waste of money because you have to get license and a lot of other things like that. So instead of building that system, not that you don't have a qualified team, but because it will be a lot of cost at the end of the day, instead of building it, you can just partner with the likes of Paystack and the likes, right? To get it done. And it will cost you even zero to none to just get it done. I'll give you the best part. Paystack allows you to even give the customer the bill, right? So the customer is paying the charges. You don't have to pay any amount. And it will cost you nothing. So in that particular case, the best idea is to actually partner. But let me give you another example. Stripe is a company. I'll give you the practical example. It's a company that is very most of us know Stripe. Very popular. Everybody knows Stripe, right? It's a big company. Now, Stripe wants to expand to Africa. Now, to expand to Africa, they would have to send somebody, like employ somebody in Africa, be sure that the person even knows the African landscape and a lot of things, get licenses, get Nigeria license, get Ghana license, get licenses in literally every West African country, all of that. And instead of doing that, they thought about it. This will be a lot of work for us, and we'll be doing test and run. We'll be doing AJ, because we might employ somebody and it doesn't work out. So instead of that, why don't we just look for another company? Now, this company works in Africa already. They work like us. They have best practices. They have everything. And luckily enough, they have users. We go to them, we give them an offer they cannot reject. And then when they give us this, when they take this offer, we allow them to continue running, and then we make money from them. And that's what Stripe did when they actually when they bought Paystack, right? WhatsApp, Instagram also did. Facebook also did it when they bought Instagram, when they bought WhatsApp, right? Oh, Instagram is booming, right? Right. I remember that Facebook actually built something like Instagram. It didn't work out. I'll be very sincere with you. It didn't work out. Facebook tried to build something like Instagram. It didn't work out. So what did they do? They went to Instagram and offered them a deal they cannot say no to. And then they bought them. Now, buying Instagram does not mean, oh, we have to sack all the staff. No, it can still continue running the way it is running, but the company owns them now. So which means they make the money, they make the control, they have control of the data and many, many other things like that without them having to build afresh. So I think you understand the basic difference between build, buy, and partner, right? So when do we build? Like I said, you build when you feel like, okay, this is part of our core offering, right? And it probably will not cost us as much to build than it will cost us less to build than to partner, right? For example, there are platforms right now that allows you to do OTP, right? You know, that's when you want to log in into your system, you know, you send them an API, they send you the OTP, then verify for you, blah, 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 right? Some people pay them to do login, to log into their own system, right? But other people might look at it and say, can build this internally. We don't need to do that, right? Another example is KYC, right? In Nigeria, KYC is a very big deal, right? You have to collect BVN. After collecting BVN, blah, 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 and there are legal rules. You have to get some license to be even able to collect BVN of customers or to be able to collect. Most people don't know this, but you need some license to be able to even ask customers for BVN, right? Not to even, I'm not saying use the BVN now. To ask customers for BVN, you need certain licenses. So again, you can think about it and say, see, I don't want to worry myself about collecting BVN and everything. Let's just export this responsibility to a different company. So you have companies that all they do with their life is they expose APIs. I explained what APIs are. That allows you to do KYC verification. So they are the one that will handle your vehicle verification. They need to verify address. They are the one that will handle it. If a customer does fraud, and EFCC is asking for the customer's information, they are the one that EFCC will go and meet. Your company does not have any wahala, right? So your company can decide we'll do the KYC ourselves, which means we collect the license and everything, blah, 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 or no, would expose the KYC part to a third-party company because we don't want to have to worry about customer did this or that, right? So again, these are the decisions that basically we factor in when we decide whether to build, buy, or partner. And with AI, it's actually becoming more and more valid. I've had people say, oh, they are going to build their own model. Baba, you want to build Claude? You can't, right? So instead of building your own model, except of course, you have the resources to handle it, like to train the data, to do all of that. Claude is already spending millions, billions, trillions, right, to train data to ensure that their system is very, very good. Why not just use the API directly? If you don't want to use Claude, there are other open source APIs that are already there that you can utilize in your system without having, and then you can just train it more with little data instead of you building the entire model yourself, right? So generally, we decide, I've given the example I give also applies to AI, building with AI. You basically decide based on these criteria, right? You consider cost, you consider how easy to implement, you consider compliance landscape and many, many other things like that, ideally. So this is how we decide if we want to build or buy, right? And obviously there are certain risk, but you can read about it. All right, quick question. Let me stop this first. Very, very quick question. What's looking like a lot already? Sorry.